All right. I hope you can hear me well. Thank you very much, first of all, spaCy, for organizing such a great event. I'm enjoying it a lot, and hopefully you do as well. So it's really great to be here. So my name is Justina, and I work as a head of developer relations at Razza. What I do is I code, but also at the same time I work a lot with developers that are using our open source software and help them figure out their issues and find out their use case as well. And at Razza, what we do is we develop open source software for conversational AI. So if you want to build your own conversational text or voice assistant, it's a software stack that you might want to use, and hopefully you will give it a try after my talk. Today what I would like to talk about are things and lessons that we learned while working with developers who build and ship their AI assistants in production. And I will tackle quite a lot of challenges that people face when they use NLP and conversational AI in real world, and I will share some possible solutions for some of them, but I really hope that what you will take from this talk is not only the solutions, but also some challenges that you will hopefully think about after and maybe share with us with how you would solve those issues yourself. So what we do at Razza is we really focus on empowering developers around the world to build their own conversational AI assistants in-house. And not only that, but we also focus on the other side, so the users. And our main goal is to empower developers to build AI assistants that work for everyone. So what we really want is that developers, when they build AI assistants, would also bridge the gap between people that build technology and those who use the technology. And our approach to achieve that for now is sharing things that we build as an open source software that everyone can use. As a result, Razza developed an open source framework, which is called Rasa, and it's completely open source and it's built in Python. And we are good friends with spaCy, because spaCy is one of the components that we use under the hood for natural language understanding. And Razza as a framework consists of two main components. First one is NLU. So developers can use it to build machine learning models that can be used to enable assistants to understand what the user means in terms of intent, so overall intention of the user input, and entities, so important details that an assistant should extract and use to decide how to respond. And another part of Razza is dialogue, or as we call it, Razza Core. So it's a machine learning-based dialogue management system which uses machine learning and real conversational data to learn patterns from how people communicate with each other and apply that knowledge in predicting how an assistant should respond at a specific state of the conversation. So depending on lots of different details, what the user said, also what's the context, what details an assistant extracted, and so on. One of the main learnings, obviously, that we noticed after we open sourced Razza is that developers do want to build their own AI assistants in-house. And even though there are a host of solutions that you probably know of yourself, and even though they provide really a quick and quite easy way to build something, they really are one solution fits all problems kind of approach. But if you asked me, I don't believe that there is one tool that fits all the use cases, the same as one machine learning model that fits all the problems. And it's really important to have the freedom to customize things, especially in NLP and conversational AI in real world. And the reasons why we see people choose open source tools like Razza or spaCy are that they are customizable. So you see all the code that is under the hood. And most importantly, you can customize things. You can add new components on top of it and really adjust the entire framework for your own use case. And that's really important because people and companies, when they want to build AI assistants, they want to build them for their own user base, their own products, and obviously that means that an assistant will have to deal with very specific vocabulary, and you have to be able to adjust and tune the models to make sure that your assistant can handle those things well. And also because it's open source, you don't really rely on that specific company or a team that is behind the project to implement the features for you. So if you need something quick, you can simply build on top of it and ship your AI assistants in production quickly, and maybe then later on even contribute and share your learnings and achievements with the community. And also what we aim as well is to empower developers. So if you are good at machine learning and you have lots of experience, you can have so much fun in tuning the models and implementing your own features with Razza and tuning the models as well. But if you're not, you can still build really great AI assistants using the default models that we provide and not digging really deeply into math behind machine learning. And we already have quite a lot of developers using Razza, and that's something that I'm really happy about, to see that community is growing. So we have over 300 contributors that contributed code, and as you can see, more than 5,000 people that are discussing Razza and conversational AI topics on our forums. So it's, I would say it's a really nice sample of users to look at and learn from how they use open source software to build conversational AI, and these are the things that I would like to cover in the next remaining time of my presentation. So first thing, I hope you will, and I think you'll all agree with me that NLU in general is hard. It's not an easy problem. There are lots of different bits and pieces that you have to take into account when you build models. But when it comes to NLU for in-house conversational AI, it's extra hard because on top of usual problems that researchers are working on, when it comes to real-world applications of NLU, so many different bits and pieces also occur, and lots of different challenges that you maybe haven't thought of before. So if you look at just NLU basics and what we do at Razza specifically for conversational AI, things look quite simple and easy. So the main goal is to take unstructured user input. For example, I'm looking for a Mexican restaurant in the center of town, and the goal is to extract structured data from that. So that means to classify the intent, so what the user input is about overall, for example, restaurant search, and extracting important entities. For example, that the cuisine is Mexican and the area is center. So pretty simple, and I would definitely agree that it's quite easy problem to solve with current technology that's out there. And the way, just for you to understand how things work in Razza, it is quite simple approach. So when we have unstructured user input, for example, like what's the weather like tomorrow, what we do is we create bag of words representation. So we look up vectors for each of the words, and here one of the options that developers have with Razza, that we can use spaCy for that to use word vectors. And we feed that into the classifier, for example, SVM, and as a result, a label for this user input is produced. So what is the most likely user input is there. And the data that is being used is here. So you can see that we provide label data, the intent labels, and examples of how the users would say those specific things, like, for example, what's the weather like tomorrow, how they would say hi, and so on. So quite simple, and I would definitely say it works pretty well with current algorithms out there and where NLP is at the moment. Sorry, but there are lots of other really difficult challenges that come up really, really often when it comes to real-world NLP and conversational AI applications. So the good old friend negation, it's still a really difficult problem to solve when it comes to real-world applications. So obviously, you can look at it in a very simple way. So for example, when you have examples like this, no, I don't want sushi, you would say, yeah, it's pretty easy to do to identify and detect negation here, because what you can do is just to simply look for not or don't words in your sentence, and then basically find what is after that. And basically, this is the part of the sentence that is negated. Great, but when you try to deal with more natural use sentences that we as humans use all the time, for example, I would go hungry before I eat sushi, where we don't use words not and don't. So how you do that? It's actually really, really difficult problem that I know it's still a really big part of research. And even this no, I don't want sushi use case is still where the state of the art is. And the model that you would probably train to solve that would basically do that. It will look for those negation words in your sentence and match the rest of the sentence. So it's really, really difficult and a big challenge still. Another thing in NLP that is challenging in real world is understanding what sentences mean and doing NLP based on that. So for example, here I have two user sentences. For example, let's say you do IT help desk, and one input says, can I help you log into my account? And another, can I give someone else access to log into my account? So let's say at first you decide that you would like your assistant to handle both of these use cases the same way. For example, just give it to the human to deal with those questions, but then let's say later on you decide that you would like to handle them differently. And those two sentences have very similar vocabulary, they have actually very similar meaning, and then if you would like to build a model that would identify them in a different way, because you would need to have two different intents for those inputs, that's really hard. And just one more example here, which explains pretty much the same case, where inputs have very similar vocabulary, very similar words and structure, but if you want your assistant to understand them differently and handle them differently, the challenge is how do you add context and how you enable your assistant to make decisions and understand those inputs based not only on the simple words or word vectors, but also on the context that surrounds the inputs that we as humans understand. And it doesn't really end there. When it comes to AI assistants in real world, entities are also a big challenge still, because when you look at named entity recognition for quite simple domains, it works pretty well. For example, extracting locations, extracting dates, and you have lots of choices to do that. You can use spaCy, you can use duckling for lots of different things. However, there are lots of different challenges even with that. So for example, extracting ranges of dates or destinations, like starting point from, let's say, from Berlin going to London, it's still really difficult to not only extract them, but also identify the ranges correctly. And the main challenge is to deal with, for example, product names, so things that are out of vocabulary. And when it comes to AI assistants in real world, fortunately or unfortunately, it's a really common case that your assistant will have to deal with lots of unusual words in the vocabulary, and you will have to train models somehow to identify them. So this is where we are coming to the next learning, that actually, even though it's really great to see where NLP and in general conversational AI field is going to, current approaches, they are quite limited, especially when it comes to pre-trained word vectors. Because as I mentioned already, your assistant in real world will have to deal with lots of unusual words, out of vocabulary words, slang, and things like that. And if you use pre-trained word vectors, which at least now are trained on quite generic corpora, those kind of words, they will have no signal when the model will try to predict what kind of entity that is, and so on. So it's a really difficult challenge, because if you want to build an assistant for your specific user base or your product, it's not going to work well. And this part specifically is something that we at Razza looked into quite a lot, because obviously we want to enable anyone to build their own AI assistant. And we worked on some research, and quite recently still, I would say, we pushed a new model to Razza software, which we called as a supervised word vector approach. Which works a little bit in a different way than pre-trained word vector approach, the one that I showed you with a simple classifier. This approach is a ranking-based model, and it was inspired by Facebook research, so StarSpace is a really good paper. I would definitely recommend reading that if you want to find more details about that. So basically, it looks at the message, all of the intents, and it learns embeddings for that, and instead of just doing simple classification, it calculates the similarity, and after optimizing the loss function, it produces the most probable intents for user input. And the best things about this approach, at least right now, obviously it has limitations, is that it learns word embeddings from scratch using the data that you have. So if your vocabulary that you would like your assistant to understand is really specific, has a lot of slang words, chances are that this model will actually be able to learn those words way better than using pre-trained word vectors. And another big advantage of not using pre-trained word vectors is that then you can build assistants regardless of the language. So since your assistant will learn word vectors from scratch, you can build your assistant in any language pretty much that can be tokenized. So there is a huge advantage for that. So now let's say you nailed intent classification and entity extraction, and everything works great. Another thing that we learned is that users will always say something you didn't train your assistant to understand. They will always try to break your bot, and it's something that I've learned. For some reason, people like to break bots, and I think it's just fun to see what can they handle and what they cannot. And we call this situation as failing gracefully thing. So while it's really difficult to train your bot to understand everything and understand every possible intent, it's at least it's important to make sure that your assistant acknowledges those out-of-scope user inputs, and that it responds to it in some specific way. And why these things happen is that it's either you don't have enough training data, or there are some spelling errors, or the users challenge your assistant by providing some really unusual or ambiguous messages. So the way we suggest developers to deal with the situation right now is to use to identify some out-of-scope inputs. So basically create an out-of-scope intent. And obviously it's a challenging thing because it means that it's an intent for pretty much everything else that you built your assistant for. But at least for now, it's one of the best ways to do that. So basically you create an out-of-scope intent, and once the users say some random thing, for example, I want pizza, even though your bot is, let's say, weather bot, then an assistant can at least predict out-of-scope intent, and based on that, deal with the dialogue later on. Also, there are some remedies built in Razza already. We called it fallback policy. So one and quite nice way to deal with this is simply look at how confident an NLU model is. And if it's not really confident, the model simply asks a user to rephrase the input. And then, depending on the prediction made on this rephrased user input, an assistant either continues or triggers the fallback and says, sorry, I cannot help you, maybe you would like to talk to a human, and things like that. So the main idea here is, again, while you cannot handle every user input in a very nice and human-like approach, at least it's really important to identify those out-of-scope inputs well and make sure that your assistant somehow deals with them in a nicest way possible. And the next thing is that NLU is not enough. So when it comes to conversational AI, it's not just about understanding, it's also about responding. And one thing that we noticed is that the understanding of what good assistant is already shifting towards more than just simple FAQ interactions, and people want to build assistants that can not really mimic humans, but at least to handle conversations nicely and quite naturally. And the main thing that we work at Razza is we are taking a different approach on dialogue management. So instead of writing rules and building state machines, what we rely on is real conversational data. And this is an example of how this data looks like. So you would basically observe how people interact with each other or with bots, and use that data to predict how an assistant should respond next. Obviously, to do that, you need data, which is, in conversational AI, really difficult challenge, because it's not the data that just lays around for some reason. But while you do a little bit more work at first collecting this training data or even generating it yourself, you see the advantages of using machine learning later when you want to ship something into production, because the main advantage of using machine learning and real conversational data is that if you want to add a new skill for your assistant, instead of going through the architecture of your state machine, you simply collect more training data for that specific skill and add it to your assistant's knowledge, and that's how your assistant improves. But it's, even though I'm speaking about machine learning, obviously sometimes you need some business logic as well. So sometimes you want to enforce some rules, a specific situation, or you know that based on your use case, there must be some very strict flow. And obviously we all know that machine learning sometimes fails, sometimes predicts wrong things. So sometimes combination is actually the best choice. And there are a few ways to do that in Razza already. Forms is one of the nicest ways to collect and make sure that your assistant collects information that it needs to execute some kind of action or do something. So for example, if in pizza ordering example, if your assistant needs to know what kind of pizza you want and what kind of extra toppings you need, you can build a form that basically enforces this behavior that your assistant will not proceed to make a pizza ordering until it actually has all this information. And another one, which is actually one of the recent additions to Razza, is a mapping policy, which is actually even simply a thing that if you know that at specific point in the conversation, specific intent should trigger specific action all the time. So a very simple example would be goodbye. Your assistant probably would always have to respond with something related to goodbye. You can use mapping policy, which simply enforces that once the intent goodbye is recognized, your assistant will respond with specific response. Okay, so I'm quite short on time, so I will quickly just skim through this. So feedback loop is also really important, so to make sure that your assistant learns over time, and that is basically the next step of building a good AI assistant, especially in production. And recently we released a new tool, Rasa X, again, completely free for the community to use. And the main thing about Rasa X is that as your users talk to your bot, you can collect all the conversations they have with your assistant, and then you can relabel them and easily add them to the knowledge base of your assistant, and then it basically learns over time for both NLU and dialogue sides. Okay, and I will quickly finish. Even though I mentioned quite a few challenges, and at Razza we try to do our best to help developers to go around these challenges, there is still a lot to do, and NLP is far from being a solved problem. But the things that we do focus at Razza is providing tools for people that they can use to build conversational AI assistants, community that use those tools, and applied research. So every single thing that we do at Razza and every research piece that we work on, we make sure that it not only translates into some kind of paper, but also a piece of code that developers can use. And here I can only encourage everyone here as well to contribute to open source if you can and if you want, because it's the best way to push really challenging fields forward, because when a group of people focuses on challenging ideas and challenging problems, it's much easier to find good and interesting solutions for that. And just a few more words. We will have Razza Developer Summit as well later this year. So if you are interested in chatbots and NLP in chatbots, I hope I will see you there. It's in San Francisco later this year. Yeah, I hope you learned something interesting, and as I said, I hope you will leave this talk with some interesting challenges in your head, and that maybe you will come to me and say, hey, I actually know how to solve this problem. That would be really cool. And if you have more questions or would like to chat about anything related to NLP or chatbots, definitely grab me or send me email or catch me on Twitter. Yeah, so thank you so much.